cams were developed to improve the process for forming flanges. They eliminate die flex and improve part consistency. A rotary cam is made up of a rotor, drive plates, a rotor cap, end stops, a rotor holder, and an activation cylinder. The rotor is a cylindrical detail that rotates into position to complete the part geometry. Rotors are typically made of SAE 0050A steel and are not usually heat treated. End stops restrict the rotor's lateral movement. They can be located at the end of rotors or along the rotor. Die makers should never rely on adjacent rotors to function as end stops, because doing so could cause the rotors to rub against each other and bind. Drive plates are graphite-impregnated wear plates that are attached to the rotor. When the rotor turns from its home position to its work position, the drive plates provide the surface for the cam slide to move on during the flanging operation. The rotor cap is mounted to the rotor holder and covers the full length of the rotor. It gives support to the rotor and provides part geometry. The rotor holder holds the rotor. It is made of SAE G3500 steel and is usually not heat treated. The rotor holder and rotor cap are keyed and bolted together to form an assembly. The assembly is bored as a unit, and then the rotor is ground to fit the board assembly. The rotor must be at least 0.02 of a millimeter smaller than the board assembly to prevent binding, but not greater than 0.03 of a millimeter, or else there will be excessive play. After the rotor is ground, it is referred to as the master, which means that the rotor holder and rotor cap must always be spotted to the rotor. The activation cylinder is used to move the rotor to its work position and back to its home position. The activation cylinder operates when the press reaches 2 program positions. When the press reaches the first program position, the activation cylinder moves the rotor to the work position. When the press reaches the second program position, the activation cylinder moves the rotor to the home position. The activation cylinder must be pressurized with between 20 and 25 pounds of air to operate properly. An aerial cam is made up of a cam adapter and a cam slide. The cam adapter attaches to the die and has a spacer behind it for making position adjustments. The cam slide is usually the component that holds the flange steels. As the press moves downwards, it reaches the first program position, and the activation cylinder moves the rotor to its work position. When in the work position, the rotor supports the part and provides the holding surface for the press pad. The drive plate should bottom out 5 to 10 millimeters before the press pad contacts the part. The press pad provides pressure to hold the part while the flange is being made. There must be at least 65 millimeters of pad holding surface along the flange line, and at least 15 millimeters of it must overlap onto the rotor cap. After the press pad contacts the part, the horizontal motion of the cam slide forces the flanging steels into the part and forms the flange. As the press begins its upward cycle, it reaches the second program position, and the activation cylinder pulls the rotor back to its home position. This provides enough clearance for the flanged panel to be removed from the press. Rotary cams have several advantages over conventional cams. Rotary cams are compact and take up less die space than conventional cams. Their rotary motion allows flanging operations to be performed using a small amount of die space, whereas the horizontal motion of conventional cams takes up a lot of die space. Saving die space is important because it creates room for adding other operations to the die, which can reduce the total number of dies required to make a part. Rotary cams also provide an extremely solid base for the die that prevents the die from flexing when under pressure from the press. This is important because eliminating die flex results in parts that are dimensionally consistent. Conventional cams require more hollowed-out space in the die. This reduces support and causes dies with conventional cams to flex when under pressure from the press. Rotary cams have very few wear surfaces, whereas conventional cams have many wear surfaces. Fewer wear surfaces result in less maintenance downtime and higher production. Space savings, high rigidity, and low maintenance make rotary cams an effective tool for making flanges.